So last year at ELC, I talked about this new project that we had just started at Linaro called Lava. And Lava is the Linaro Automated Validation Architecture. It's kind of the automated testing framework that we use for running all of our builds through automated testing and getting results out and storing those results and visualizing them and everything from top to bottom. Last year when I talked about it, we had a lot of things actually working at the time, but since we had just started, it was about this time last year, and we had just started the project, there were still a lot of components that were still in the planning phase. A year later, we've made quite a bit of progress, and that's what I'm hoping to show you today is kind of an update on where we're at now and where we're going. So about Lava. Lava is completely open source, first of all. Like everything we do in Linaro, we're pretty much open by default. We use Python for everything and Django for the web pieces. It's got an extensible front end. There's a piece that handles device management and automatic deployment of our images to the boards. In addition to that, we have XML RPC APIs that can be called remotely, and command line tools that actually make use of those. So if you need to do things from a command line on that machine or a remote machine, it's pretty trivial to do so. You don't have to use the web interface for everything. There's tools for automating test suites on both our Ubuntu-based and our Android-based Linaro builds. And we have support for a lot of the popular low-cost ARM development boards that are currently on the market. And in addition, support for new boards is really, really easy to add, and we're adding more boards all the time. So the way Linaro uses Lava is first and foremost for the daily automated testing of the images that we produce. This is really important because unlike some test frameworks where you're only really concerned about pushing a new kernel and you don't care about the root file system or the bootloader or any of the other pieces, we're actually interested in pushing the entire stack across and pushing like a whole new Android image or a whole new Ubuntu-based image. And I mean, in the future, who knows? It could be some other types of images that we support as well. And even within the Ubuntu and the Android images, we kind of support several different flavors of those. So we're pushing the whole new image for every single test. Since we use a scheduler to pick an available machine, we can't be sure what was on the system before. And I mean, let's face it, these are test machines running test images. Even if we could be sure what was on the machine before, you probably wouldn't really want to trust it anyway. Additionally, we also do kernel tests, but we mainly do that by pushing the kernel into a hardware pack, and I'll kind of talk about that a little bit later, and then deploying a whole new image with the kernel, typically basing it on an image that we've already tested before and we know and trust that it's already good and it's not going to fail because of something unrelated to the kernel that we're pushing in. We use it for Android and kernel continuous integration testing that I'll talk about later, and for platform enablement testing. So what does Lava look like? I guess that really kind of depends on how you're asking the question and what you mean by that. Architecturally, it looks kind of like this. I mean, this is just a basic diagram. We've got a web user interface. All of the web components sit under a piece called Lava Server, and that handles the back-end pieces. It handles authentication. It handles the extension points for adding new APIs and new views within the server framework. If you're familiar with Django, the server piece is like a Django project, and the extensions that we'll talk about later are Django apps. The primary extensions that we have are the dashboard and the scheduler, but there's also a number of other extensions that can be written as well. For instance, we've got some that can change the way the views work. On the back end, underneath all of that, there's the command line pieces, like the dispatcher, the piece that talks to all the boards, Lava Test and Lava Android Test, which I mentioned briefly earlier, that handle actually running the test suites for you. If you're talking about from a hardware perspective, I kind of imagine that our setup looks a lot like test automation frameworks in other shops as well. I mean, we have servers that kind of drive everything. We have your general network infrastructure, switches, routers, and whatnot. Console servers are pretty important because if you're booting things that are changing the kernel especially, you want to be able to see the raw console output, and in some cases control it from the serial console. Networked PDUs, and racks of ARM development boards. Visually, it kind of looks like that. We've got stacks of these boards. This is a picture of a couple of our racks. We currently have 3 racks with an assortment of different boards from our member organizations. PDUs, servers, other infrastructure components, like I mentioned. As you can see, we get pretty decent density by stacking the boards. We could do a lot better, actually. In fact, I've got a rack design that was way more dense than this, but the guy that kind of handles the lab and hooking everything up and everything said, you know, that's not going to work because it's a trade-off, because we want to cable these things up sensibly, and we want to actually leave ourselves a little room for instrumentation. We're starting to add things like wireless access points and Bluetooth and USB attached devices to test, and eventually probably some devices to do power measurements and things like that. So we don't want to pack ourselves in too tightly. And then, of course, I mean, there's always the problem of maintaining it. If you pack everything in too tightly and you need to get it aboard because it's bad or you need to do some maintenance on it, you kind of paint yourself into a corner there if you're not careful. So the Lava components. This is a list of the main components that we have in Lava. It is not by any means an all-inclusive list. There are various pieces not listed here, but they're mostly libraries and helpers. I'll show you some of the more interesting ones later, but many of these were things that we didn't have last year. Some of them we did. For instance, the dashboard, which has changed quite a bit, and Lava Test was there, but Lava Android Test wasn't, and the scheduler was completely new, and the server used to be part of the dashboard, but now it's split. So there's a lot of differences from before. One of the important things to keep in mind is that Lava is very modular. So if there is a piece of this that is interesting to you, you can use just that piece. We have some people that are just using the web front end for results storage and visualization. And then we have some people on the complete other end of the spectrum who are using just Lava Test by itself, or just a dispatcher and Lava Test to run their tests in an environment where they may have to be deploying boards, or they may even already have it deployed and they don't care about that piece. They just want to run tests on it. So it's really kind of up to you how much of it you want to use. But as I mentioned, it's all open source, and you can replicate the complete stack on anything from just a laptop hooked up to a single board all the way up to a full lab environment like I showed in those previous pictures. So let's start with the scheduler. Why start with the scheduler? Well, the reason I decided to start with this is because it's kind of the primary entry point for your test jobs. If you're running the full stack and you say, okay, I want to get this test job running in Lava, this is what you submit it to. And there's a command line for doing that. There's an XML RPC API that you can submit it to directly from a program. On the visualization side, you can kind of see that it shows you a list of all your devices. It's kind of cutting off the bottom there, but you're not missing too much down there. The top part there is just showing a list of the devices. It's showing 1 to 10 of 50 entries. You can use the search box there to filter the results. On the bottom, that's the active jobs that are currently running. And not just the running jobs, but the submitted jobs. So if there's any queued up jobs that will be scheduled later, you'll see those displayed down there as well. And with that, you see kind of a brief description of the job, the device the job is running on, and the submit time and all of that. Another view from the scheduler side is if you want to look at a particular device. So if you want to see, okay, what are all the jobs that have ever run on this device, and see a complete history of it. So the device details page shows you that. It shows you all the jobs ever run. It shows you if there's any tags associated with that board. So if you have specific pieces for instrumentation that are hooked up to that board that you want to give the scheduler hints, only give me this type of board if it's got this tag associated with it, you can do that. It shows you the device status, and you'll see a button up here that says put into maintenance mode. The purpose of that button is if you want to take a board offline, you can click that button. You can even click that button in the middle of running a job, and what it'll do is it'll put it into a status called going offline, and at the end of the job, the scheduler daemon, which is kind of a back-end piece as a scheduler, will see that it's going offline and put it in offline mode instead of putting it back to idle. And that way you can do your maintenance on it and then set it back online later. So this view is also part of the scheduler, and this is kind of one of the more interesting views if you're somebody who's submitting tests. This is the job detail view, and it shows you quite a bit of things. It shows you when the job was submitted, when it actually started, so you can tell how long it was waiting. If it's finished, it'll show you when it was finished, of course. And the other thing that you don't see here, because this is a running job, is when it's finished, under views down there, there will be a link to the results. So you can get at those easily. Kind of in this main panel here is a limited summary of all of the logging messages that have happened, and you can filter those by different logging levels. But you can also get at the complete log, even while the job is running. So you can see the full serial log and all its gory details, which is really useful to have. If you're debugging something, you really need that. It's a little bit much to pick through if you're not trying to debug a problem, which is kind of why we made this view and had just the logging messages here. But it's necessary when you need it. And of course, you can cancel the job from this page if you want to. You can also do that from the command line. The dispatcher is a piece that the scheduler daemon talks to. So one thing that I kind of glossed over with the scheduler is it has a back-end piece for the daemon, and it's actually split into two parts. The reason we did that is we wanted to be able to do live upgrades on the system, including upgrading the scheduler, without having to quiesce everything and make sure we did it at a time when there were no jobs running, because we're kind of at a point now where we've got jobs running almost all the time. The secondary piece of the scheduler is the piece that gets spawned when it figures out, okay, this is the board that I'm going to run it on, and then it talks directly to the dispatcher. The dispatcher is a piece that actually talks to the individual boards. Mostly that's driven over a serial interface, because that's the one thing that we can be pretty sure is going to be up all the time. We're dealing with these boards at a point where they're not so early in bring up process that we can't assume that the serial console is working, but there may not be quite far enough along that we can be sure that the network is going to work. So our general philosophy is we don't typically trust the network unless we really need to for some test or for some piece of infrastructure. We prefer to run everything over the serial port, including things like U-boot. So the way we deploy boards right now is we have the test image written to the same card that we boot off of for our stable image, and then we intercept U-boot and force it to boot into that secondary image. So the dispatcher runs the actual job, which is written in JSON. If I have time, I might get to a point where I can show you that, but I'm not sure if I'm going to get that far in the slide, so we'll see. But it's a pretty basic schema that we use, and it's based around the idea of doing these things called actions. And the actions themselves are just kind of a limited set of things that we provide for doing things like deploying the images, running the tests, and submitting the results back up to the server. Actions can take parameters. So for example, the one that lets you deploy an image to a board lets you also pick which image you want to send it. And you can add new actions. You can add them in tree, or if you want to kind of install this yourself and add your own actions, but they may not be something that you want to push upstream, or they may not be something that anybody else would care about because they're very specific to your environment. You can maintain those as a plugin and still continue to upgrade the dispatcher, and it will just continue to work. Currently, we support Linaro, Android, and Ubuntu-based images for deployment, but there's no reason why it couldn't be extended to support installing other types of images as well. It just happens to be that those are the things that we've added support for currently. One of the new things that we added since last time I talked about this was local board configuration. Previously, there was some of the stuff was kind of hard-coded and it was really bad, but it was kind of just in the interest of getting up and running quickly, and you had to edit some Python files, but when you upgraded, they would get blown away, so you had to keep a copy of it. So that's all handled a lot better now. We have configuration at the board level, at the system level, the board level, and at the board type level. And it's all inherited. So you can, for instance, configure boot parameters for a type of board. And then if you've got a specific board that has some differences to it that you have to handle differently, you can set the same configuration for that particular board, and it'll override what's in the board type config. And the dispatcher is one of those pieces. Like I mentioned, it's pretty modular. You can use it standalone, or you can kick it off from the scheduler. The scheduler doesn't have to start it. Lava test, again, one of those pieces that it's kind of hard to provide a really interesting picture of because it's kind of command line piece. Lava test and Lava Android test I grouped together because they kind of go hand in hand, and they're actually forked from the same place. The reason we did them separately is because it turns out that Android is a little bit different from our Ubuntu images. On the Ubuntu images, it's a pretty fat client that we have there, and we can do a lot of things with it. We can install Python on it. We can run full test suites in it. We can even build the test suites in it. We can install the tool chain and build things. So we have a lot of options to do there. We don't really have to do things remotely. Android prefers to do things like over ADB, and it works a lot easier that way. So we do use ADB for running the Android tests. And the other thing is they tend to run very different tests. So the same tests that you run on your Ubuntu builds are not going to be the same tests you're going to run on Android, and vice versa. So that way we kind of keep the separation there and say, okay, this is the set of tests that we have enabled for Android, and this is the set of tests that we have enabled for our Ubuntu images. It's not really about the individual tests themselves. So I mean, some test frameworks are about providing an easy mechanism for creating new tests. We kind of take the other direction and say, we want to use the existing test suites that are out there. We want, if you do write a new test suite, we want it to be really generic, and all you have to do is write a really thin wrapper piece that tells us how to install it, how to run it, and how to parse the results. And that's all we really need to interface it with this. And Lava Test and Lava Android Test do all the rest of the work. Once you give it those pieces, they do all the rest of the work for taking the results out of your run and putting them into a format that the Lava dashboard can understand. The other thing that's kind of neat here is we support out-of-tree tests now. So this is really useful for a lot of reasons. If you have a test that's covered under some specific licensing, as we probably all know, there are some test suites that you have to license, and they've got all these rules, and you can't release it, and you have to be real particular about releasing the results of it and everything. Well, you obviously don't have an easy upstream place you can pull that from and install it. So you may want it to get that from an internal source. Or you may have a test suite that you have to run internally in your organization that's not released outside. You know, I mean, we prefer that everything be open source, of course, but I mean, in the real world, we know that that's not always the case yet. On the other hand, there could be a situation where you're trying to develop a new test. And we've seen a lot more of this lately as more of the developers within Linaro are trying to get their tests into Lava. They start working on something, and instead of wanting to test it out locally, they've actually been pushing it into the system, which I think is really cool. And they've been doing that by using out-of-tree tests and writing it so that instead of saying, okay, install this known test, it says, okay, point over here and install this test from my people.linaro.org server or my or some other external website that I'm going to pull it from. And these, like the dispatcher, can be used standalone. So this was kind of one of the older pieces that existed before we even started the rest of Lava, and you can actually use it just by itself on a machine to run your tests. So the dashboard. The dashboard is really mainly about storing and retrieving the raw results of the tests. It is one of the web pieces, so it provides the XML RPC API and command lines for submitting tests into the system. It also has some other pretty useful things. You can pull results out of it. You can even synchronize two dashboard servers, which is pretty cool. There's a lot of reasons why you might want to do that, but I mean, generally speaking, we don't do it right now, but it does support it. So some terminology to go over here. It's really hard sometimes to find the right set of terms to describe something because it seems like all of them are already used in 30 different places. But so when I talk about these things, just to kind of level set what terms I'm using here, when we talk about a stream or a bundle stream, It's just a way of organizing result bundles. And result bundles are just a set of test results submitted after a testing session. It can be a single test run. It can be multiple test runs of different test suites. It can even be multiple test runs of the same test suite. Think of it as kind of like the results of an entire session where you're usually deploying an image and running a bunch of tests and then submitting the results from it. The test run itself is the results from a single test suite. And a test case is there's going to be usually multiple test cases within a test run. So Lava Server is the framework that we use for all of the Lava web components. It ties it all together, and it does some pretty important things. Notably, it provides the framework for adding XML RPC APIs. So if you want to extend that, you can. It also provides the authentication backend. And we have a method for generating tokens, and then when you need to auth to the server, you just provide the token, hopefully over HTTPS, but that's the recommended method. The dashboard and the scheduler are examples of some extensions that we have, but they're not the only ones. And it's really kind of the main place to look at for adding new functionality to Lava. So if Lava doesn't do something that you want it to do, this is where you go. And you can either extend that on the command line side, or you can extend it on the web side. So extending Lava Web Server. If you want to write an extension, you can use some of the data that is in existing extensions. So if you want to get at the test results that are stored by the dashboard, or if you need to get at the job information in the scheduler, you can do that. You can add new models for storing new things. So one of the things that we see done in extensions sometimes is denormalizing data or even storing new types of data. Creating visualizations is one that I think we're going to see a lot more over the next year. What I'm hoping is to try to get all of our working groups kind of centered around, okay, we're doing all this testing, we're getting all these test results into Lava. Now how do I get out the things that I care about, and how do I see them in a way that means something to me? And that's not something that I can easily answer for them, but that's something that we can work with them on and try to get them to help us mock up, and we can kind of help them do something with this. You can add new features that are not provided elsewhere at all, and you can even extend the API. So here's an example of an extension that somebody wrote recently, and this was actually demoed at the Linaro Connect last week. Were any of y'all at the Linaro Connect? That's too bad. It was really cool. I mean, there was a lot of stuff at the Linaro Connect and this is just one of the things about Lava that was demonstrated. So one of the neat things about this is it was done by somebody that wasn't even on the Lava development team. They had never touched it before. They had never even really done anything with Django before. He knew some Python, but he was kind of dreading getting involved in this because he saw it as like this big overarching thing, and he was worried that it was going to like be a huge time sink for him. And kind of the big crux of his talk was just about how easy it was, and once he kind of finally kicked himself into doing it, he got going pretty quickly with it and was able to do something pretty cool. So, I mean, the way this kind of got started is he was doing some benchmarks on Android, and he was providing these reports, but he wanted to do it through Lava and do it in a more automated way. And so he started pushing his results in there and figured out how to write this view that gave him the same kind of output like he was looking for. And that's actually deployed on our server today, and it's in production right now. So one of the other things I mentioned earlier that we do is the continuous integration loops. Our Android team was really kind of one of the front runners in trying to really drive this effort to do continuous integration using our test automation system. And as part of that, our infrastructure team built this tool called the Android build system. And that's kind of a picture of it here. It's essentially just a front end to Jenkins, if you're familiar with that. Lava itself doesn't provide any build mechanism. We're using Jenkins for a lot of the build stuff right now, and it does a really good job with it. It could grow that someday, I don't know, but right now we don't have any compelling reason to move off of Jenkins for the build stuff because it works really well. once it's done with a build, it'll submit a test job to the Lava scheduler if it was successful. Obviously, if it wasn't successful, then there's nothing for it to test. But then at the end, the test results are submitted to the Lava dashboard. And also within that, one of the things that they do is they have kind of a summary page. And I don't show the top part of it here, but it kind of starts off with all this information about the build, how you would get it running if you wanted to just download it yourself and put it on an SD card. It points at the test results. It points at the artifacts themselves to download. And this is actually pulling from the Lava server. So we provide a view that sends back JSON if you give it the job number. So all this system knows, it's a completely separated system. All it knows is that it submitted this job and it gave it back a job number. And so it stores that and then sticks this in here to grab the results out dynamically. So whenever you load this page, if there are any test results out there yet for this, it'll link to them and it'll actually show you the test results in a table. And it doesn't have to do it like that because it's just getting it back as a blob of data in JSON. So it can render it however it wants. So the kernel CI loop isn't really too much different from that. We still do the builds in Jenkins. We have several upstream trees as well as Linaro trees that we try to detect changes in and then do the test and then submit the results to Lava dashboard when it's done. Same kind of deal. Jenkins builds the kernel. If the build is successful, it submits the results. The only difference here really is it submits a build result for it as well, because that's something that our kernel engineers really care about tracking as a separate test result, is did it build. And then we have a visualization plugin for that as well that kind of shows a summary of all the builds. Well, there's another page I don't show here that shows a summary of all the builds. And what this one does is it shows a summary for a single board of all the trees that are tested on that board. And you kind of see, it'll let me do it. Yeah, down at the bottom you see the change set, whether the build worked or not, which dev config it used, and the results of all the steps. And LTP fails, but I mean that's because there's a couple of tests in it that fail, and LTP just returns a fail status if anything fails. So deploying Lava. I think I've got a little bit of time left. Yeah, I'm doing good. If you want to deploy Lava yourself, it's actually pretty easy to do. We start with a piece called Lava Deployment Tool, and it's really just a big script that handles all the setup tasks for you. Because Lava uses a database, it needs to make sure that Postgres is installed. It needs to set up the database user. But I mean, other than Postgres and Apache, I think that's about it. There's really not much else that it needs externally on your system. It creates a pretty clean environment for you using Python virtual env. If you're not familiar with Python virtual env and you're doing Python development, you should really take a look at it. It's very cool. And what it does is it kind of gives you a sandbox for everything that you're in, all the Python packages that you're installing, so that you can kind of keep everything self-contained. And one reason that's cool is because using that method, you can have multiple instances on the same server. For instance, if you want to have like a production instance and a staging instance, and you want to test your changes in staging and then push them to production, it's really useful for doing that. It copies everything that you need to install offline for installs, because we're grabbing a lot of these things and their dependencies from the Python package index. And it turns out that sometimes it's very time sensitive trying to install things from there. And if you have enough of a network delay, it can cause it to kind of get a hiccup and not want to work right. So the way we're installing it now is it makes like this bundle of everything that's going to install. And then you push that bundle. And one of the things that's nice about that is it actually enables you to do offline installs. Additionally, there's backup and restore commands that are really useful, not only for production systems, but also for testing. So if you have a lot of test data in there and you want to do some Lava development and try out your changes using live data, you can just restore that data into your test instance. And it also handles upgrades. So as I mentioned in the previous slide, I kind of glossed over it. You can either download the tarball of Lava Deployment Tool. It's pretty much just a script and a couple of config files, or you can branch it directly from Bazaar. Once you have it, the first thing you do is you run Lava Deployment Tool Setup. And all this does is just make sure all the pieces are there that it needs. It installs virtual env and pip and UWSGI and any dependencies that we need. And you only have to run this one time. So if you've run this once, you don't have to run it again. Next step is you have to create a bundle. So this requirements file that gets specified is basically just a list of all the things that it's going to need to install. And I know you probably can't see that very well, but I'll try to do a demo of it here in a minute if we've got time. I think we will. The bundle is, like I mentioned earlier, it creates the Python bundle of all the things that you're going to need based on this requirements file that just lists the components that you want. As I mentioned, you don't have to install everything. You can just install certain pieces of it, and this will automatically resolve the dependencies for you and install just those pieces. It can be moved to another system once you've created the bundle and installed later. And so one of the things that we're doing now is we release a pre-built Python bundle of all of the stuff in the release from the Lava project on Launchpad. So if you don't want to build the bundle yourself, you can actually just grab it from there and install it. So the next step in the process is you just run Lava Deployment Tool install. You give it the name of the instance, production, staging, test, my instance, whatever you want to call it, and then you tell it the bundle you want to install. If you're upgrading, the process is really similar to that. You just basically replace install with upgrade, and it'll upgrade from everything you had before to the new versions of everything that are in the bundle. And it's basically going to take you through and ask you a whole bunch of questions, make you confirm the username you want to use, and you have to type next a whole bunch of times. But then once you get through it, it just goes. And then it'll create the databases for you, and it'll run the migrations. If you've ever done Django development or web development in general, it turns out that people don't always think about everything they might need in their database from day one. So it's often useful to be able to extend your database, add new tables, add new columns, and normally you have to migrate that yourself, but Django's got this pretty cool plugin called South that lets you kind of automatically resolve the migrations. And this runs all of that for you. So if you're upgrading or installing new, it'll make sure that your database is at the proper level for your code. Next thing you're going to want to have is an admin user. So the admin user can access the Django admin panel. They can give permissions to other users. They can add bundle streams, new devices to the system. They can set up a virtual environment. I'm sorry, you set up the virtual environment first to do this. And the way you do that is you go to the instance directory where it was created, serve Lava instances, then your instance name. And this is just virtual env. You source the bin activate file. And that basically just sets your paths and everything correctly. Then to create the user, you run Lava server, manage, create super user. Again, if you're familiar with Django, you've normally got this thing called manage.py for doing a lot of commands like this. And Lava server just provides a front end to that. That can also be extended to add new commands. Making a bundle stream. So as I mentioned earlier, a bundle stream is just kind of a way of organizing your test results. So if you want to push some results into a system, you want to create a bundle stream to do this. You can kind of think of it as like a Flickr stream or a subdirectory or something like that. It can be done from either the admin tool or you can do it from the command line. If you want to do it from the command line, the way you would do it is you would just run Lava dashboard tool, make stream, and then you give it the URL for the dashboard for the API, which is going to always have /rpc2 at the end. And then you give it the name of the stream. The important thing to consider here is that /anonymous/test/ you need to have the trailing slash on the end. It does expect that. And that anonymous just means that it's kind of like a public, anybody can submit to it. So in this case, it's not a private one. So pushing a test result. Next thing you want to do is actually have a test result in the system. So I'll show you this in just a second. I'll go through this process real quick. And what you would do is just Lava dashboard tool, give it the URL, and give it your bundle that you want to submit. So let me actually try to break the cardinal rule of presenting here and try to actually run a demo of this. Let's see. I've got a KVM session running on here that I can use for this. All right. So the first thing I want to do is remove the test instance that I had on there before, because I was actually playing with this last night just to make sure it worked. Oops. So I've actually downloaded Lava Deployment Tool here. I'm going to run that. And this is going to actually just destroy everything that's in that test instance. It's going to remove the user, remove the database, everything. Destroy. Oops. If I can type my password. Caps lock. There we go. All right. Let's see. And then the next thing that we're going to want to do, as I mentioned earlier, is create the bundle. In this case, that takes a while to do, and the network here is kind of flaky. So I actually built the bundle in advance. Oops. So that's an old one. That's a new one with the release that we just did yesterday. And lava.py bundle. Yep. All right. So like I said, it's just going to ask you a bunch of questions. I want to use the username as is. Yes, yes. All right. Now it's going to ask me if I want to enable the scheduler in this instance. The reason you might not want to enable the scheduler is, in fact, I'm going to say no here and go ahead and let it run in the background. You might not want to run the scheduler because it's either just for testing and you're not actually going to schedule jobs in it, or you might not want to run the scheduler because it could be a staging instance. So if you have a production instance and a staging instance and you have the scheduler running in both and you take a backup of your production instance and put it in your staging instance, what's going to happen if one of those jobs is in submitted state and it knows how to get to it? You're going to have this conflict where you're going to have two schedulers trying to start running jobs on the same board at the same time. So that's the reason we kind of ask that there. And this is just basically doing a pip install of all the pieces that it needs. Takes just a couple of minutes. That's doing a build of the UWSGI stuff. It's installing Lava Server. Creating the databases. And now it's running the schema migrations for the database. And it'll be done in just a second. There we go. And that's it. That's pretty much it. So now you have like a full install of all the stuff that we just released yesterday of Lava. And we do monthly releases. So it says down here at the end to start it, you're going to run sudo start Lava instance with Lava instance set to test. So I'll just copy that, run it. And now if I go out here, I can go to that same URL. It's that. And there it is. So, I mean, I could go to the scheduler and look at jobs and everything, but, I mean, there's really nothing there. Dashboard, bundle streams, it's totally empty. But let's actually fix that. So let's make a bundle stream the way I mentioned before. So we're going to get over to here. cd/serve lava instances test. Then activate. And we're going to do lava dashboard tool, make stream. You know what? Let me just copy this. That'd be easier. Give it the URL. It's on localhost, so I can just use that /anonymous/test/. I'm going to make a bundle stream called test. So if we go back to here, we'll see, yeah, we've got a bundle stream now. We don't have any test results in it, but we've got a bundle stream. So what I did earlier is I did use the dashboard tool to get a bundle off of our live web server so that we could use it. Let's see, where did I put it? Right here? Yeah. So I can do lava dashboard tool put, give it the URL again, tell it which bundle to put, and that'll actually import it into here. If I'm quick enough, I can see here, yeah. Right now it's saying it's there, but you don't see much about it. It says deserialize no. Once it gets it in, you give it a brief second, it'll deserialize the data, and you'll see, oh, look, we've got 2,263 test results in this run, 17 fails, and that many passes. And so we can go to that and let's look at the Wi-Fi enablement tests. And so from there, we can see all of our test results. They all passed. Let's look at one more interesting. Let's see, what's one that's going to have some failed? POSIX test suite is a big one. It's got like almost 2,000 results in it. So the neat thing about this tool is this is a jQuery thing called data tables, and it lets you do filtering and sorting. So I can sort by this column and just see the fails at the top. If I want to see just the functional tests, I can just start typing here, and it'll filter them out for me and everything.
What's the measurement?
Measurement is a good question, actually. So we don't treat test results any differently depending on whether they're qualitative or quantitative. So pass-fail results are stored the same way as benchmarks. The only difference is for benchmarks, you may specify a measurements and a units. So all of your test results will have either like pass, fail, skip, unknown associated with them. But if and only if it's a benchmark, you'll also have the measurement there as well. But yeah, the dashboard doesn't actually treat that any differently. So where was I here? Here. Going back to here. So yeah, that's what we just did right now. And I mean, I could kind of stand up here and talk about this all day and like bring a board and show you like running a test on it and everything, but doing a live demo, I'm kind of pushing my luck already here, so I decided not to do that. And also in the interest of time, I kind of wanted to just kind of give you an example of some of the basic usage of it and also help you illustrate how easy it was to kind of get it up and running and get started with it. It's pretty trivial to do. This is a thing I showed last week at the Linaro Connect. It's just kind of a Gorse demo that I did of every scheduler job that we've run through the system. So the scheduler came online mid-2011, and we kind of started off with just a couple of Beagle boards and Panda boards, and we were running tests on those. And it's kind of grown over time to where now we've got about 50 different boards in there of a variety of different types. Beagle, XM, Panda, MX53, Snowball, Origin boards. We've even got a couple of V-Express boards in there. And so, I mean, it's kind of a cool way to see just kind of how it grew over time. And all it's really showing here, you see the numbers out there. Those are the job numbers as I start and stop. Obviously, much time sped up. You see the board type, like you'll see Origin down there. We just had one Origin board for a while. And then we got a shipment of a whole lot more. And you see it kind of blossom out right there, actually, right on cue. And it kind of just blossoms out from there. And you see, like, now we've got 10 Origin boards in there. And we'll be adding more, I'm sure, soon. And they're all running jobs daily as well. So far, we've got nearly 13,000 jobs that have been processed since we first put the scheduler online, and I think it was like June or July of 2011. And it's still running great now and growing.
Where is this video available online?
Yeah, actually, I just put it on YouTube. So, and I'll post the results somewhere. the URL for it somewhere else too. But anyway, that's pretty much it. As I mentioned, it's all open source. We've got growing documentation. I won't pretend that it's absolutely complete end to end, but we're adding more documentation by the week. I mean, we just pushed in a couple of significant updates to the docs over this past week. You can get that at lava.readthedocs.org. It's also linked to from the documentation link in Lava. We have the source code. All of it's available on launchpad.net/lava. Our system is validation.linaro.org. You can't actually start jobs on it because you have to have an account and permission to do so. That's something Linaro members can do, but it's not. Our system for usage isn't publicly available, but all the source is. So you can actually set up your own if you want to. IRC, we're on #Linaro on freenode.net. If you're looking for me there, I'm P. Lars, but if you get on that channel and say something about Lava, there's several people that would probably be ready to help you. And we also have a Linaro validation mailing list as well as the Linaro dev mailing list that everybody's subscribed to. So any questions? Yeah?
How would this plug into like a live board farm that's used for development as well as testing?
So if you're wanting to use the boards sometimes for automated tests, well, what you could do is you can actually go into the scheduler and set a board to offline. And one of the things that we recently added to that, because we realized we needed it, was a reason associated with taking the board offline. So if somebody called me up and said, you know, hey, we need to get on this type of board, I don't have one, can you let me on to the test lab to just use a board for a little while? You could absolutely do that. I would go in and mark the board offline and say, hey, Matthew needs to use this board for the next 2 days. Don't bring it back online until you talk to him.
That's literally what we're doing. We're running tests when the board's not used.
Yeah.
We don't have, our boards aren't involved.
Yeah, so I mean, the boards, the way we do our deployments, the boards have to be provisioned for doing this. But I mean, that could even be as simple as putting in like a different SD card when you want to put it in the mode for testing and boot it up and set it back to online and you'd be ready to go.
Can you say a little bit more about how the tests are written? If someone writes a script in the test, or?
So the individual test suites themselves?
Yeah.
We can run whatever. So I mean, we run things like POSIX test suite and LTP, which are written mostly in C, and then there's other things like the Wi-Fi enablement test suites, I think, are mainly in Bash. We've got other things that are in Python. Right. So I mean, we're not really defining how your tests have to be written. In fact, we're not even defining how you need to get the results out of them. We have to have the results in a special format. I mean, we've got to have some standard format to get them into our database. But what we do is we provide Lava Test and Lava Android Test, and I mean, there may be other variants in the future as well. But all those do is they handle taking existing test suites, and you give it a very thin wrapper that tells it how to install it, how to run it, and how to parse the results. And it takes that information, uses it to run the test, get the results out, and put them in a format that the dashboard can understand.